Hey folks, welcome to Advent of Code in F#, day 7. We ended day 6 getting our 2 stars, doing a somewhat of a naive brute force approach, but it worked. I saw a lot of people online use a simple mathematic equation, a mathematic equation which is a lot faster even. So if that's interesting to you, you can find alternative approaches. And that's what I find amazing about Advent of Code. There's always lots of ways to try solving these puzzles. But my 6 AM brain always brute forces as a default. That's the easiest thing to wake up my brain in the morning. So let's take a look at day 7. Camel Cards. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. All airships are cool. It drops you off at the edge of a vast desert and descends back to Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts for the sand, yes, come with me, I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what look like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island, making it hard to even get there. Normally they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts. They need to fix the machines. You've already assumed it'll be your job to figure out why the parts stopped when she asks if you can help. You agree automatically. Yeah, it's not our first year helping all these elves. Because the journey will take a few days, she offers to teach you the game of Camel Cards. Camel Cards is sort of similar to poker. Oh, I know nothing about poker, except it's designed to be easier to play while riding a camel. In Camel Cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled 1 of ace, king, queen, yada yada yada. The relative strength of each card follows this order, where ace is the highest card and 2 is the lowest. Every hand is exactly one type. From strongest to weakest, they are 5 of a kind, 4 of a kind, full house. What's that again? 3 cards have the same label and the remaining 2 cards have a different label. Then you have 3 of a kind, 2 pairs, single pair, highest card. So those are the hand types. Yep. Hands are primarily ordered based on type. For example, every full house is strictly stronger than any 3 of a kind. Yes, if they have the same type, 2 hands, the second ordering rule takes effect. Start by comparing the first card in each hand. First card sorted? Probably. If these cards are different, the hand with the strongest first card is considered stronger. If they have the same label, move on considering the second card, yada yada. Yeah, that makes sense. So it's a lot of tie breaking if we have identical types. So these 2 are both 4 of a kind, but the highest card is... Ooh, no. So it's not so ordered. So 3 through 3, 2 4 of a kinds, but the first one is stronger because the first card we encounter is stronger. That's not what I would have expected. I'm glad we read through the entire problem description before going into it. Okay, so they're both a full house, but 7, 7, 8, 8 is stronger because its third card is an 8. Yeah, okay. So this was an edge case I would have not expected. All right. To play Camel Cards, you are given a list of hands and their corresponding bid, which is our puzzle input. So for every hand we have a bid, yeah. This example shows 5 hands. Each hand is followed by its bid. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, second weakest gets rank 2, and so on up to the strongest hand. Because there are 5 hands, the strongest hand will have rank 5. So it'll be a 5 times multiplier for the bid. The first step is to put the hands in order of strength. Okay, so order by strength. 3 2 T 3. What's the T? The T? King, Queen, Jack, 10. Okay, the T is a 10. 3 2 10 3 King is the only one pair. Okay, so that's the lowest. That was confusing. What's the best card in this, or the best hand in this list? 3 of a kind. Do I see? Oh no, there are 2. 3 of a kinds is a tie, and there's a stronger first card. Okay, so this sounds like a parsing, scoring, ordering problem again. Let's take a look at our input. How many hands do we have here? A bit, but not a lot. A lot. 1,000. That's encouraging. Okay, let's grab the example as well. And let's start parsing these. Yeah, let's use some union types to represent the card. A card strength, or no, let's just convert it. Let's just keep it simple. Let's make them numbers. So a card's rank is just an integer from 2 to an ace. What is that? 10, Jack, Queen, King, Ace. You know what? Let's make it explicit. I feel like encoding this thing today. Is it useful? Nope. Is it fun? A bit. Jack, Queen, King, Ace. The only painful part is specify which one is higher, but that's just one function away, so it's okay. So that's our ranks down. A card is just a rank, right? Yeah. Okay, so I'm just gonna name this a card. A card can be any of these cases, and a hand is just a list of 5 cards. 1 2 3 4 5. Yeah, but it's just a card list. Okay, let's parse. And let's keep this in type land, not assignment land. There we go. Yeah, let's parse. I'm gonna put my examples and my inputs together and drop my type definitions in here. So let's parse. Example is a list of... Why did I not copy the example? I did, I just did not run it. Okay. Let's parse. Oh yeah, we also have this, what was it, the bid? I'm gonna keep it in the hand structure. Are they all integers? Quick looky look. Yeah, they're all below 1,000. Yeah. Parse hand, which takes a line that's a string, and it returns this hand type. For that, we need to break on space. We've been here before, so it's the cards and the bid. If we split line on string, yeah, cards are just, we can iterate over them, so it's just a string. We can do a sequence dot map parse card. Those are the parsed cards, and we can make a list of that, so we can provide it into our cards record. And our bid is just the bid parsed to an integer. All we need now is a parse card function. And all our types should line up nicely. They do. Okay, so this is the second part where our parsing or union type takes a bit of a hit, but that's okay. Let's better match. So it can be any character. 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. I have never learned any batch commands, so bear with me for a second here. King and Ace, there we go. That's not an ace, there we go. I'm already regretting my decision, but I'm gonna stick with it. It helps my brain wake up a bit, but I don't think today will be too much of a problem, or at least not part one. Let's crash if we encounter anything we don't expect, just in case. Unknown card rank, and that's a character. Let's print that out as well. Okay, fail with F. It's a formatting string. Yes, yes, okay. Let's see whether or not we can parse our hands. We are parsing something, all right? Something with a King 10, Jack, Jack 10. And a bit of 220. Oh yeah, it's the second to last. Then you have Queen, 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 Jack, Ace, 43. Yeah, that looks correct. I'm happy. We have our hands. What's next? We need to classify them, give them types. Yeah, let's do that first. So these are the rules, right? Let's grab the rules, or let's put them next to our code. There we go. This can go. There we go. Yeah, let's give every hand a type. That'll be useful. The tiebreaker is always the same, right? We go from left to right, highest card is considered stronger. Yeah, okay, so yeah, we can just write a function that defines the type for a hand, or for a list of cards. Let's define a type. And it can be several cases. That sounds like another union type for me. So a hand type is either a 5 of a kind. Yeah, we don't need to know which kind of a 5 of a kind for our tie breaking or for our ordering. So let's just keep it like this. A full house, 3 of a kind, 2 pairs, 1 pair, highest high card. There we go. So those are all the hand types we have, and this is a function that defines the hand type given a hand of cards. And everything is indented incorrectly. That's my bad. There we go. Five of a kind. That's... are we going to do something fancy today? Yeah, I feel like doing something fancy today. Let's use an intermediate F-sharp concept called partially active patterns to define this hand type. I'm going to quickly refresh my own memory. What the exact syntax is for what I'm trying to achieve here. Banana clip? Yeah, banana clip. What does it have to return? I can just return anything if you do this. The partial thing, was it with options? Quick refresher. Yeah, options. Okay, I know enough to get started. So I'm gonna write a function that matches, that investigates a hand, and for each of those cases I'm gonna define a separate function, and then this define hand type will pattern match on all the different variants, and that will be composed of all those separate functions. It'll get more clear once we have one or two of these down. So let's define a function that identifies fives of a kind. And I'm going to use some very exotic syntax here with a lot of pipes and underscores, but it'll make sense in a second. So is 5 of a kind is a case we want to recognize, and we get our cards in, and that's just giving us, and you have to return an option if you use this partial active pattern thing, but that's not very relevant. We'll see where this ends up in a second. But let's say we have an is 5 of a kind function, or something like this that recognizes 5 of a kinds. Do I have to return something actually? Is it useful to return something? Not really. Let's take a quick look again. Partial active patterns. Int value. Int value. I don't really care about the int value. I just want the case. Can I return an empty sum? A sum of units? Let's give it a try. Unit, that's the type. What's the instance? This is the instance. Okay. Let's see if this works. So let's pattern match on cards. And the case is that it's a 5 of a kind. So then we can return 5 of a kind. And otherwise, let's just do whatever high card. So this should all compile. And whenever this function returns sum, then this pattern match will succeed on the is 5 of a kind case. And if it returns none, we fall through to the next matching arm. That's a bit of the idea of partial active patterns, where you break up your pattern match in separate functions, and it's like an open-ended list. That's why there's this, there's maybe some other union cases here, but we have not identified them there. So this pattern match has to figure it out, given all the arms. So it's a bit of a rounded way to do it, but I think it matches nicely with what we're trying to do here. Now we have like a place to define this is 5 of a kind logic, which is really easy actually. So let's do that right away. So if all the cards are the same, so if we put them in a set and length is 1, then we have a 5 of a kind. Otherwise, we don't. Why is cards an integer? Interesting. Why does it think it's an integer? Oh, because I'm comparing against 1. I need some parentheses in there. There we go. Yes, so this lines up. I think we can recognize 5 of a kinds. Let's quickly verify. By writing a quick test for this 5 of a kind case. So define hand type for a list of cards that is whatever, 2 5s or 5 2s. 1, 2, 3, 4, 5. And that should be 5 of a kind. Yeah, it is. So we're good. We're good. Ooh, this formatting. Okay, there we go. So that's 5 of a kind down. Let's do the other ones quickly. Or as fast as we can, at least. 4 of a kind. What's the best way to do that? Let's just group by. We could have done that for 5 of a kind as well. So let's do cards, sequence, group by, identity. And if there's one of the groups with a 4 length, we're done. So groups any exists. If there's a group where the group, what is group here? What's the type? It's a tuple, okay. So the card and the instances. If the instances, if we have 4 anywhere in the groups, we have a 4 of a kind. And if we have a hit, then we have some is 4 of a kind. I'm gonna keep the is terminology here to make them separate from the actual patterns of the actual types. So we have some is 4 of a kind. Yeah, else we have none. We don't even need to know which number. No, we don't even need to know that just yet. I don't like how my formatter is formatting these cases very differently. Where's my 4 of a kind? I did not define that yet. Okay. There we go. Now we have a 4 of a kind. Let's write a quick test for that as well. To make sure, let's put a 3 somewhere in there. And that should be a 4 of a kind, right? Quickly verify. Yeah. Cool. What's the next one? The value is unused. Why is it saying that? Visual Studio is like the official IDE, and it only works half. The functionality for F# is a bit sad, but okay. Let's get to an interesting case. Full house. That's actually very similar to 4 of a kind. We can do the same approach, I think. Again, we group, and there should be a group of 3 cards and a group of 2 cards. So if we have a 3 of a kind and we have 2 groups, then we're good. And groups, that's a roundabout way of saying we have 3 and 2. There we go. So if we have a 3 of a kind and we have 3 groups, that means that the other group are all the same. We have a full house. And we don't even care about which cards build up the full house. I'm so gonna regret saying that for 5 times already, for part 2 probably, but we'll cross that bridge when we get there. So 3 of a kind, 2 pairs, 1 pairs, all the rest is just going through the motions, I guess. So next one up is 3 of a kind. And we don't need to make sure that it's not a full house before we check the 3 of a kind. As long as we do this pattern matching in the correct order, like the hardest case first, we can assume, at least for the define hand type function, that we won't incorrectly tag something as a 1 pair while it actually would have been a full house. So that's not a problem because pattern matching works top to bottom. So is 3 of a kind. We have a group of length 3. That's literally what we have here. So this is our 3 of a kind check. So it's very explicit, but it's very tedious to write code with union types instead of integers. But over halfway there, I'm not gonna complain. I'm gonna continue on. 2 pairs. So it's the find all the groups where we have a pair. Number of pairs. We say count every group by whether That's too difficult. Let's take a step back. So filter the groups where their length is 2, and then count how many of these cards we have, or how many of these groups we have, and that's the number of pairs. And if the number of pairs is 2, we of course have 2 pairs. And that one, I made it sound like I was very sure. That one I would like to see. That one I would like to see in a test. So let's write a test for our 2 pairs, because I have this inkling of a doubt. Oh, we broke something. Interesting. Five of a kind. That's not true. Two. Okay, did we should not even run this test? What? Okay. So I was taking a look at 2 pairs. Yeah, that's the one I'm having an inkling of a doubt. So it's 2, 2, 3, 4, 4, for example. That should be what was I calling again? 2 pairs. I'm calling this to be 2 pairs. 4 of a kind. That's not true. High card. Why is it defaulting to high cards? Because we don't do 2 pairs. Okay. Yep. Nope. It's still defaulting to 2 pairs. Oh yeah. It should. Okay. So yeah, that works. That's 2 pairs down. I think 1 pair might be very similar. So let's quickly hammer that out. Is 1 pair. That's the number of pairs. If it's... Yeah, we could do it in an easier way. We can do the set thing again. But no. Let's keep it consistent. So is our 1 pair. Then we have the 1 pair case. And in all other cases, I think it's safe to assume high cards. So these are the hand types. Let's enrich our hands with their hand types. That's something we did before, so I'm gonna map every hand to the hand itself. We don't want to lose track of the hand and the hand type. And let's just keep that a tuple for now. And I'm conflating hands and cards, but the hand was a list of cards and the bid. We need a bid in just a second to determine scores, or I don't even know what we needed to do, but we're going to need this. So let's take a quick cross check, because we have not tested all of these cases, right? So what do we see? Let's go back to the example really quickly. We have 1 pair, 2 pair, 3 of a kind. And a high card. Is high card, is that true? One, two, three, four, five. 1, 2, 3, 4, 5. No. I think we already have a bug. Let's investigate. So 3, 2, 10, 3 king is the only 1 pair. And I am labeling it as a high card. So there's already a bug in there. And probably in the 1 pair logic. Let's take a look at the 1 pair logic. That's an interesting one to fail. I don't see the problem, so let's write a quick test, and I'm gonna grab the case that's failing. So this should resolve into a 3-3 into a 1 pair type. And it's not. So let's make sure we understand what's happening here. Or before I put it in there, I'm gonna put it right next to the code. There we go. So define hand type. For this example should be 1 pair, right? And it falls back to high card, which is the catch-all, which means all of these cases are failing, including is 1 pair, which means that this logic is incorrect. Interesting. Okay, where is the bug? I'm going to start playing around with this line by line. You could like debugging, but debugging without a debugger. Oh no, it did the formatting thing again. Let me first grab this thing. Let's name this thing cards so we can play around with it in the REPL. So, what are the groups according to this code? 3, 2, 10, king, and there's a group with 2. So yeah, that looks exactly. Number of pairs. Number of pairs. What am I doing here? Yeah, that's correct. Sorry, I thought I spotted the problem. I did not. There is 1 pair in there. Huh? So this is matching. Then I would expect it to do this. Huh? Huh? I'm just gonna do this a couple of times on the beat because I don't understand what just happened, but the bug has disappeared. Probably a REPL issue where I did not send the latest code to the interactive window. So it's very fluent and fast if you do it correctly, but if you make a mistake like I probably did, you can look for bugs that don't even exist. So yeah, slight detour, slight problem, but our tests are green. We are good. I think we can define hand types. No, we were verifying the example, so let's quickly finish verifying the example to make sure. So we had a 1 pair, we had a 2 pair, and we have 3 of kinds. 3 of kinds, 2 pairs, 2 pairs, 3 of kinds. Yes, that looks to be correct. Then we need to order them, sort them, so we can determine ranks. And we sort them by type. And if there's a tie amongst types, we sort them by going from left to right, finding a highest card. Yeah. So these are the hands. Let's sort them. I'm just gonna build on this pipeline. Yeah, why not? Yeah. Sort by projection. Will we get there by projection? Or are we going to have to do a comparison thing? I don't actually know how I do this. Sorting by like a number, I know I can do easily. So it's a function that takes a type and returns a key. So we need to make something, a function that returns something that is comparable. And we could put the tie breaking in there already, but that's hard because we then have to compare adjacent things, and the sort by only takes the current element. Yeah. How do you do comparison with a custom comparator in F#? Is there an easy way? Custom sorting functions. Sort with, interesting. I've never heard about sort with. Yeah, that's exactly what we're looking for, probably. It takes a comparer. Yeah. Compare hands. And let's delve into the enriched data structure, but the comparison function does not need to know about ranks or bits, at least. Doesn't need to. No, it doesn't need it. So let's keep it out of here. Let's keep this function as context independent as possible. And what does a comparator return? An integer. This is what always messes me up. What does it mean if a comparator returns a positive number, a negative number? So let's look that up. Sort with? What was it? Sort with, yeah. What's the official docs? Maybe this learn, maybe this hit up. Example. Oh, I like this documentation. So, this is the sorts a list of pairs using a comparison function that compares string lengths and index numbers. Nope. Too dense to parse. What does it mean to determine oh god, we're getting shoved back to this doc. Okay, so let's take a second to look at this. If a bigger number, what does that mean? Actually, we can just play around with it. What are we doing here? Sorting this thing first by string lengths. No. Oh yeah, lowest string length first. Okay, okay, that makes sense. And then indices. Yeah. Okay, so 0 is bigger than 2. What is it? Comparing my string length first. I'm assuming that 0 means equality. Bigger means positive. Negative number means less or equal or less. Let's verify that assumption. But so I think h1 is bigger than h2. Yeah, we can actually verify that, right? Let's make a list. So if we always say it's bigger, sorry? Value compare hands is not defined. Okay, just need to send it to Rebel. So this is saying h2 is bigger, is bigger, is bigger. This is saying h2 is smaller, smaller, smaller. h1 is smaller than h2, so it's... Actually, no, it's way too confusing. I'm just gonna type something out, and if the order is incorrect, I know I switched my positive and negative things. But this is exactly what I hate about this .NET comparison thing. And if I take a look at other languages, I think it's Rust. They did a very good thing. Let's see if I can find it. Where they don't have this madness where you're playing around with numbers, but they have like a union case that says like, oh, by the way, it's larger or it's lesser, and not like it's -1 and you figure it out. So yeah, a little bit of a pet peeve with this thing. But okay, enough of a rant. I'm getting old, enough of a rant. Let's just hammer out this compare hands function. And for that, we need to just take a look at the type of the hand. So we actually do need the type of the hand, which is what we're throwing away here. Let's not throw away the hand, and let's provide it to our comparison function. We need both the hand and the hand type. So let's just pipe in the tuple. Yeah, let's pipe in the entire tuple. So this takes hand 1, type 1, hand 2, type 2. Should still compile? It does. And let's give the type system some information. Okay. Let's do the tiebreaker first, and then we can make some assumptions in the following code. So if h1, no, if t1 equals t2, then it's highest card wins left to right, right? I'm just gonna put that in another function, the tiebreaker. Takes 2 hands. And it returns one of those magical numbers. If someone has like a quick mnemonic, a quick hack to remember what these negative, positive, zero numbers means, I would be interested. Because this has been tripping me up for 10 plus years now. But okay. Let's do the tiebreaker first. So we go from left to right, and if we see something that's different, we take the highest wins. So sounds like a zip to me. Zip is a function on every list that takes 2 lists and combines them element-wise. So if you have 2 lists of 3 elements, the first element that the zip will return contains the first element of the 2 lists. The second element is a tuple containing the second element, but it'll make sense in a second. So if we zip these 2 lists together, we have 1 list containing tuples that one by one correspond to the indices. Is a zip? Yeah, a zip is probably... is that the best way to do it? Is there always a tiebreaker? If you have 2 identical hands, what happens? Is that like a case we should be worried about? Nah, let's not worry about identical hands. So, how do we figure out the tiebreaker? You know what? Screw it. The zip thing is too hard for my brain. So I'm just gonna do a for loop. Am I able to do a for loop in my head? What are we actually trying to say? So we're actually trying to say, go over every index, look at the card in that position. If one of the 2 is the biggest one, that hand wins. Okay, now transform this to functional F sharp. Wait a second. Wait a second. Hand is a card list. Card is 2. What does this do? Does the order of the cases matter? Yeah, it does. You know what? I think we can just say... this, actually. Just compare those 2 things. Let's give it a try. So tiebreaker 1, 2, 3. Oh yeah, they have to be card lists. Yeah, let's keep it hands. So let's have our tiebreaker. Yeah. Okay. We don't really need the bits, right? No, we don't really need the bits. So let's not put the bits in there for this tiebreaker. This conflating a hand with a card list has bit me twice already. That was a silly silly decision. Okay, but now we're back. So this is identical, that's true. In this case, I would expect the second hand to win. And then it's saying something like, oh, minus. So this is less than this, okay? And now it should be a positive number, right? Because the first hand is bigger. And if these are the same, then now we should have a negative number again. And then we should have a positive number again. Yeah. Okay, this works. Yeah, it would be interesting to figure out how to write the comparison ourselves in a functional way, but that's not what we're here for today. We already saw some exotic F-sharp stuff with these partial active pattern matches, so that's for another day. Let's continue on. We have our tiebreaker. Otherwise, we don't have our tiebreaker. We have our hand type match where we need the tiebreaker. So yeah. So now we know there are no identical hand types, so there will be one winner. So one hand type will be strictly better than the other. So we can do an exhaustive pattern match. Which they are always different. So if T1 is the best one, what's the best one again? Five of a kinds. Yeah. Then the first one wins, so it should be a big number, right? Was that what we said? I think that's what we said. If it's the other way around, if we have a 5 over there, is this correct? Let's try this already. Let's do a compare. Let's do a compare with 5 of a kinds in there. I don't feel like it. I want to see it. I don't want to type it. So I'm just going to do something quick and dirty here. I'm going to define an alias for the number 1 that says it's bigger and smaller. And if we turn out that this is incorrect, I don't know why I'm having so much problems with this, but then we only have one place to fix this bug, right? So it's a concession. We have 5 of a kind down. Can we just go down the list this way? Yeah, we know they're distinct because the tiebreaker is up there. Okay, so here we go. Five of a kind, 4 of a kind, full house. Is there a smarter way to do this? Probably. 5, 4, full, 3, 2 pairs. What else do we need? 1 pair and high card, right? We're already hitting 160 lines of codes, and we're hitting the 48-minute mark. Wow. I think I will be one of the slower entries today, but that's not a problem. I have time. Okay. This rule will never be matched. Oh, it figured... Really? How does it figure this out? Wait, what are all the cases here? Oh yeah, it makes sense if we wildcard the other end. Yeah, it's true. This rule will never be matched. Okay. Yeah, so big question mark here. And otherwise, I'm pretty comfortable. Let's see. We sorted stuff all right. 1 pair, 2 pair, 2 pair, 3 of a kind, 3 of a kind. That's exactly the wrong order. Or if we do it like this, we can easily rank them actually. Yeah, that's maybe even better. It's going to be very confusing for future me. But I'm gonna do it. So define hand type, compare hands. This puts them in the wrong order, unintentionally, but we can leverage that fact. I'm gonna put a comment on there. Future me will be so pissed. Sorts in reverse order. You're welcome. If we have them sorted, we can rank them. We don't want to rank them with an offset by 1, right? The first one was rank 1, yeah. So how are we going to do that? What's the cleanest way? Let's do a map with an index. And it takes int and the element, and we can return I plus 1 and the element. So now we have our ranked hands. The 1 pair is a 1, and the 3 of a kinds. Is the order of 3 of a kinds correct? 4 rank should be 10, 5, 5, check, 5. Yeah, and the 5 rank should be queen, 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 jack, ace. Yeah, that appears to be correct. So this is our ranking, and then we can score these hands, multiplying each hand's bid with its rank. Yeah, so let's do that. Rank hand, where we multiply the rank with the hand's bid. Sorry, what was bid? Bid was a hand and a hand type, so hand, hand type. Yeah, so this gives us the score for a hand, and we need to sum them up to total winnings. So this is one big old pipeline. Give me 6,440. That is correct. Happy enough. Let's see if this works for our input as well. So in order to do that, we just need to parse the input instead of the example. You know what? Let's write a solve function. Just because we can. Even basic refactorings like a extract method don't work in Visual Studio, or at least not for me. Let's see, let's put my money where my mouth is. Or at least the resharper combinations don't work. I don't know if built-in Visual Studio stuff works. But that's a rant for another day. Yeah, so this works. Let's solve our input. We have a big-ish number. Good enough. We got our first star down. Cool. Before we drop into part 2, let me quickly copy paste my file so I don't destroy all our beautiful work for part 1. There we go. And let's take a look at part 2, shall we? To make things a little more interesting, the elf introduces one additional rule. Now, J cards are jokers, not jacks. Wild cards that can act like whatever card would make the hand the strongest type possible. Now that is a cool twist. Cool, cool, cool. To balance this, joker cards are now the weakest individual cards, weaker even than 2. No! This screws up our order. Let's do that first. Let's make J our weakest card. And let's put a comment in there. Order of these cases is mucho importante for comparison. And let's put our Jack below, lowest ranked card, and it has become a Joker, which will hopefully break our parsing somewhere. Yeah, and we can parse into Joker. Everything works. Everything works. Okay, so that was the first part. We have the weakest cards and they have become Jokers. The only thing that we need to change is... Ooh. So actually we can't define the... Yeah, we can define the hand type up front. We have to just make Joker the strongest possible. But J cards are the weakest individual cards. That rule we have patted down. We just need to do the wild card thing. J cards, can pretend to be whatever card is best for the purpose of determining hand type. So this is now considered 4 of a kind. Makes sense. For the purpose of breaking ties, J is always treated as J. Of course, so it's the lowest valued card. Yeah. The example goes very differently. Yeah, okay. Probably will work. Probably will work. Okay, so only thing that changes is when determining the hand type, the J becomes whatever makes the hand the strongest. How will we approach this? I'm sorry, that was a long think. How will we approach this? There can be up to 5 jokers in a hand. There's 2 ways to do this. We can think about the problem really hard, come up with a smart approach, or we can just brute force it. And whenever we see a hand with some jokers in there, we generate lots of possible hands where we replace joker by whatever, by all the possibilities, except maybe joker, and then just brute force our way through. That sounds like a easy first attempt. Not a fast first attempt, but an easy first attempt. So that actually means that we can still use the same approach. Sure. Can we though? This is actually what changes, right? The hand type changes. We can still do this, define a hand type with cards, but we can put a layer around it or put a layer in between where we do some magic with these cards and just generate lots of possible hands by replacing the jokers. And then just taking the best of all those possible hands. Yeah, so this is our point where we start to change the algorithm. Let's keep define hand type, but let's do a bit more work in here. So this will still be relevant, of course, but this thing, right, we have to explore some options here. So, potential hands, I'm looking for a word where like we replace all jokers by all the possible alternatives. And this will blow up our space a bit. How do we do this? How do we do this? How do we replace jokers by all options? If there's 1 joker in there, it explodes to 12-ish. If there's more jokers in, it explodes to a lot more. This will grow very fast. Is my brain telling me I need to take a break before I'm exploding jokers? It might. It just might. And I'm seeing that we are hitting right up on the hour marker, so I'm gonna continue after a quick coffee break. I'm very happy we got part 1 down. I hope my brute force naive approach of exploding jokers will work, but I guess we'll find out soon. This was part 1 for Advent of Code and F# Day 7. Hope you had fun, and I'll see you soon for the next one. Bye bye.